Hello, lovely people. Welcome to a new video on circular measure. In today's lesson, I am going to build concepts. I'm going to build concepts on circular measure. Circular measure. All right. And this is my worksheet. I'm going to work with you. Now, when you come across the formulae in circular measure, do you wonder how they come about? So this is the purpose of this video, to make you understand how we derive the formulae. To start with, I am going to talk about circles. Okay, the area of a circle, to be specific. We have treated the equation of a circle, but today I'm not going to talk about the equation of a circle. I'm rather going to talk about the area of the circle. When I say the area of a circle, it's simply the region bounded within the circumference of the circle. Now, the area of a circle is simply given by pi r squared. Then the circumference, which is the distance around the circle. Circumference. Can you pause the video and say it? The circumference is 2 pi r. That's the circumference. Now, in this circle, I can have a sector. You know, there are so many ways of cutting your circle. The two ways of cutting your circle, the popular ones, you can either cut your circle like this. If you cut your circle like this is a sector. If you cut like that, that is a segment. Okay, let's say this is the center of a circle O. So there are two main ways of cutting a circle: sector and segment. Now you should also know about arc. The arc is a portion of the circumference of a circle. You know, this is the circumference, the distance around. So just a portion of it, just a portion. Let's say from here to here. This is an arc. It's the smaller arc, so it's called the minor arc. Minor arc. Now the bigger one is called the major arc. The bigger one is called the major arc. Okay, so now the region bounded by the arc and two radii. You know, radius is the distance from the center to the circumference. Distance from the center to the circumference. So this is a sector. Can you see? That's a sector. And this is a segment. So now the segment is the region bounded by an arc and a chord. Okay. When you say a chord is simply a straight line that touches two sides of the circumference. It touches the ends of the circumference. The biggest chord is the diameter. The diameter passes through the center as well. Okay. So now you're going to study more about sector and segment. But before then, you should know about the length of an arc. The length of an arc is given by, you see, an arc is simply a fraction. It's a fraction of, or in layman's term, you say it's it's a portion of the circumference of a circle, okay? So a portion is the same as a fraction. So let's say like here is theta. So is theta. What's the total angle of a circle? It is for 360 degrees. And so 360 times, off is times. Circumference is given by 2 pi r. Do you remember from trigonometry that 360 degrees is the same as 2 pi? Hope you remember. So my friend here and my friend here will cancel. 2 pi and 2 pi will cross out. So I'm going to be left with what? R times theta. So the length of an arc is what? R theta. Now let's come to the area of a sector. The area of a sector is simply given by a sector 2 is a portion of the area of a circle. Now you know that 360 degrees is the same as 2 pi. Area of a circle is given by pi r squared. Okay, so let's say here pi and pi will cross out. So I'll be left with what? Half r squared theta. So that is the area of a sector. Okay, now this is a small sector, so it's called the minor sector. The bigger one, this side, the bigger one we call the major sector. I'll leave you to go and find the area of that for me. So fast forward, let's look at the perimeter of a sector. Perimeter. So basically you have something like this. Here's theta, here's r, here's r. And this side is the length of the arc. So here's r theta. So the perimeter of a sector is given by pi r plus r, which is 2r plus r theta. So it's given by, they have r in common. So you can factorize that one and you get this. So this is the perimeter of a sector. Okay. Let's come to segment. Okay. Let's say I have a circle here. My beautiful circle. Very good. So let me draw a straight line here so that it touches the ends of the circumference. So what it forms is what is formed here is what is called the segment. Okay, very good. So now let me join this side. Let me join this side here. I join here, then I join this side. It looks very beautiful, right? I'm sure you are jealous of my circle. So let's say be theta. Yes, r, yes, r. Okay, I can actually find the area of my segment this side. Now the area of the segment is simply given by the area of the sector minus the area of the triangle. Now area of a triangle is, before you know that one, area of a triangle is, let's say you have a triangle with dimensions A and B so that they form an angle theta. The area is simply given by half A times B times sine theta. So the product of the two dimensions and the angle at which they meet, the sine of the angle at which they meet. This is the formula for finding the area of a triangle. Any triangle that has a known angle and two other sides that meet. So this, in this case, this triangle, the area is going to be half r times r, which is r squared, sine theta. Okay, so the area of the segment is simply, what's the area of the sector? Half r squared theta. We found it previously, is here, minus the area of the triangle, half r squared sine theta. Can you see they have something in common? What they have in common? They have r squared, half r squared in common. So I can factorize that one. I put my theta here and I put my sine here. So this is the area of a segment area. Fast forward, let's move to the perimeter. The perimeter of the segment. You can see clearly that the perimeter of a segment is the length of the chord plus that of the arc. We know the length of an arc already. The length of an arc is what? Rho. Okay, r theta, rho. Most of my student call is rho. Now, the length of a chord is what we don't know. So now let's find the length of a chord. Okay, so we are given some like this. Just a moment as I clean this side. Okay, yes, r, yes, r. So I'm going to draw a straight line so that the straight line bisects, a straight line from the center to the chord bisects the chord. It's a principle that we learned in equation of a straight line. If you have forgotten, please go over your notes. Okay, so here it will bisect it. So if here's the whole length is 10, it's going to divide into 5 and 5. So if here's the whole length is x, let's say the whole length of the chord is x, from here to here is x, it's going to divide into x over 2, here to be x over 2. Okay, so here is 90 degrees. So the angle here, what happens to the angle here? It is bisected. Perpendicular bisector bisects your angle as well, and then bisect the chord. So right now you have something like this. Can I redraw my diagram? Okay, I have something like this. So here is 90 degrees. This is theta over 2. Here is r. Can I wipe this one? Let me do so. Okay, so now I want to find, can I turn this one upside down like this? Let me go for my ruler. I'm just going to turn it upside down. So you're going to have the angle. The angle here is theta over 2. This is the hypotenuse, which is still r. Now I want to find, if I want to find sine of the angle is the same as the length of this. Mind you, the length here is the same as x over 2. So here to be x over what? 2. So here this is the same as x over 2 divided by the hypotenuse, which is r. And you know that is the same as 2r. So if I make x the subject, the whole thing will come and multiply this. So I'm going to get 2r sine theta over 2. Okay, good. So this is the same as the length of the chord. So the length of the chord is given by 2r sine theta over 2. Before you do this topic, it's important for you to know trick before you get here. trigonometry. I have a video on trigonometry, so you can watch it. All right, to give you a clear understanding of what you are doing here. We are just applying trigonometry. Now that I know the length of a chord, I can come and find the perimeter of my segment. Can you predict what this shape looks like? Does it remind you of anything? This one looks like half of your lips. Okay, that's the chord, and that's the arc. From here to here, arc. From here to here is chord. So you're going to find the distance around this. Let's see what you're going to get. So the perimeter is simply, what's the length of an arc? Rho. What is the length of the chord? 2r sine theta over 2. You can factorize the r so that you're going to have this. Now let me tell you a mistake, some mistake a lot of students make. Many students cancel this and this. Please, the 2 in front here is affecting the whole trig function. It's not affecting the angle. Okay, it's affecting the whole function, the whole sine function. So please don't cancel that. It's a terrible mistake a lot of students make, and they always lose their marks. So please don't cancel anything. Just leave it like that. Okay. Now we have spoken about segment. We have found the area of a segment. We have found the perimeter of a segment. We have also found the area of a sector. We have found the perimeter of a sector. Now we have also, mind you, also found, my bad, we have also found the area of a triangle to be half AB sine theta. And if it's isosceles triangle, you know that you're going to get what? Half r squared sine theta. We have spoken about it. Now we are going to learn a little circle theorem properties, which will help us here. Circle theorem properties. So you should know a little bit about it. Don't worry if you don't know anything about it. I'll just give you the important ones that you need to know. You don't need to know everything. Just a few of them will be okay for you. Now I have my circle here. Let's see this. This is the first property. The first one I have spoken about already, but I'm going to repeat it. I'm going to let it be the first one. I spoke about it just some 5 minutes ago. Okay, so let's say this is a circle and this is a chord. Now a line from the center of the circle to the chord will always what? Bisect it. Don't forget. It always bisects this line. So if here is 5, here will be 5. If the whole thing is, if the whole thing is 10, it's going to divide into 5, 5. Or if it is 12, it's going to divide it into 6, 6. Please don't forget this, okay? So if I just join the radii here, you know, 2 radius is called radii. So we say that the a perpendicular from the center, a perpendicular line drawn from the center of a circle, in this case is O, is, or I should say, will bisect the chord. So if a perpendicular is drawn so that it passes through the chord, it will always bisect the chord. It's from that principle that I found the length of the chord. Okay, I applied it here, 90 degrees. Now let's come to the second one. Are you ready for the second principle? I'll be ending the next 5 minutes. Are you ready for the second principle? Now, the second principle says that, just a moment, a line part, the diameter makes an angle of 90 degrees at the circumference. Okay. So this like the whole thing is like the whole thing here is like a semicircle. Okay. The understanding is that the angle at the center is twice the angle at the circumference. So if here is 180, here will be what? 90. Okay. So some people call it this one angle in a semicircle. Okay. So the diameter will always make an angle of 90 degrees at the circumference. We are going to apply this one a lot in a lot of questions. Let's come to number three. Number three, I just mentioned it. Okay, let me just apply so that you don't forget. I just said that the angle at the center is twice the angle at the circumference. Okay, so for example, if here is 60 degrees, here will be what? 30. If here is 80 degrees, this side will be what? 40. Do you understand? So the angle at the center is twice the angle at the circumference. The angle at the center is two times the angle at the circumference. So I call this one angle at the center. Okay. So the angle at the center is twice the angle at the circumference. Now let's come to another one. Now this one has to do with the radius. The radius is, let me draw a line like this, straight line. And let me draw a tangent. You know, in Cambridge, they like asking question that has to do with tangents. So let's bring tangents here. Okay. Now, the radius is always 90 degrees to the tangent. So the fourth one, radius is perpendicular to the tangent or to a tangent to a given tangent. So I'm building the notes with you. It's like you're preparing our stew. If you are preparing your stew, you have to cut your vegetables. If you are going to fry meat, you have to do your spices. Okay, you have to create your sauce for the chicken. So that's what we are doing. So in the next topic, we'll be applying all these things you have mentioned here. Then the last one that you need to know, very important, a lot of questions. All right, so let's look at the fifth theorem. Now in this case, we have a point. Okay, there there's a point. There's a common point here, so that a line drawn from the point to the circle is tangent to the circle, like this. Beautiful, right? So I put here, let's say this is my center O. Then I connect. Okay, let me connect here too. Isn't it looking beautiful? So now I have, this is my radius. This is also my radius. Okay. Now there's something interesting about this line from the point. Let me say, let's here be A, here let's here be B. Now the distance of A to P is the same as the distance of P to B, or B to P. Okay. This and this have the same length. Then another thing is that a line drawn from the center to the common point P, the diagonal. You know, this figure is a kite. This figure is a kite. There's something interesting about a kite. It has two triangles with the same shape. The two triangles are said to be congruent. Okay, they have the same shape. So what this diagonal does is that the big diagonal, the longest diagonal, there's one here and there's one here. I want to focus on the longest one. The longest one will bisect the angle here. So if here is alpha, here will be alpha. If this side is theta, this side will also be theta. And the another interesting thing that we know already from the fourth theorem is that the radius makes an angle of 90 degrees to the tangent. Okay, an angle of 90 degrees. So here basically you have a right angle triangle. I'm taking one of them. Let me take a let me take this side. Okay, I'm taking one of them. So you have a right angle triangle, B here. Then here you have at the top you have P. This is theta. This is alpha. And this side is O. Now OB is the radius. Okay. Now whenever you have this, you can use SOHCAHTOA, or you can just use the basic trig ratios to find one of the dimensions. They can ask you to find the length of PB. You can see that here PB is the height of your triangle. Okay. Normally they want you to find the area of this triangle. In order to find the area of this triangle, you know that area of a triangle is half base times what height. So half base times height, will be using it. So if you want to find the length of this side PB, which is the same as the height of your triangle, you can just use what SOHCAHTOA. So imagine I have radius, I have this. I can say tan alpha is equal to PB over what? Over R. So PB is going to give me R tan alpha. So I can find the area of what? The right angle triangle. Then when I finish, I multiply by 2. Okay. If I multiply by 2, I get the whole kite, the area of the kite. So that's something interesting. All right. Another thing is that there's another way of finding the area of the whole thing. You know, a kite, the area of a kite is given by half times the product of the diagonals. So let's say there's another diagonal here. If you can find the length of BA and the length of OP, and you multiply them by half, that should give us the area of the whole region here. That's the kite. Okay, so that's another thing that you need to know. So you have to be very smart with this question so that it will waste your time. So basically, normally when they ask you this question, what they want to do is that they want you to find. So normally they'll ask you to find the perimeter of this region. So you know that this one, this is the same as the length of the arc plus the length of BP and EP. That's the perimeter. However, if you are finding the area is the area is going to be the same as the area of the area is going to be the same as the area of BPAO. That's the entire thing. That's basically the figure formed, the kite. And this is the same as the area of what? The two right angles. The two right angles. Minus the area of this sector. This sector. Okay. So sector OBA. Or I should rather say sector BOA. So that's it. All right. Before I go, there are two more things I need to show you: the cosine rule and the sine rule. Cosine rule and the sine rule. The cosine rule is given by if I have a triangle like this and I have an angle here. Let me call the angle C. Angle C. There's a side here C. Here's A. Here's B. The rule says that C squared is equal to A squared plus B squared minus 2AB cos of the angle. Okay, cos of the angle there. So notice that the angle here corresponds with the what? The C. If they ask you to find B, imagine you have to find B. Let's say the angle here is B, angle B. Then B squared is equal to A squared plus C squared minus 2, the product of the AC. The product of the two. Cos the B is opposite to what? Angle B. Can you try the third one? Okay, so if you take the third letter A squared will be equal to B squared plus C squared minus 2BC. That's the product, okay? Cos 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 of the angle, what's the angle here? A corresponds with what? Angle A. So it's basically the angle that's opposite the line. Okay, so yeah, that's it. But let me just take one for the purpose of this lesson. I just wanted to show you how to, just in case if you are looking for a different angle. But for the purpose of this lesson, let me just take only one. So it's basically the angle, the letter here is the same as the angle opposite it. That's what I'm trying to show you. So let's make cos C the subject. Cos C, cos of the angle C is equal to negative 2ab c squared minus a squared plus b squared. Oh, let me do it the other way around to be faster. Let me bring this one to the left. 2ab cos of the angle. So now this will give me a squared plus b squared minus c squared. I divide both sides by ab, ab, 2ab. So when I do that, I'll get something like this. So cos of this angle will give you this. So if I want to make cos C the subject, I'm going to get this. Let me bring cosine of my angle. Yeah. So you should know a little bit of trick before you touch this topic. Very, very important. Okay. Now, the other one. Let's say here's angle A or angle B, and there's B here. There's angle C and there's C here. Angle A and there's A here. Okay, mind you, I said you have to focus on the line and the angle opposite it. So if I take A is A over sine A is equal to, if I take B over sine of the angle B. What about C? Can you get C? C will be what? C over this sine of the angle C. This is the cosine rule. So any two of them equated together, any two, you don't have to use the three. In fact, you can't use the three. You can in math. There's not like two equations like this on the same line. No, any two of them, just a pair of them is always correct. Okay, so you can use a pair of them to calculate. Just select two of them to calculate your work. We shall see how we apply it in our questions. Okay, so in today's lesson, we have looked at a lot of stuff. We have spoken about segments, the perimeter, the area. We have spoken about the length of an arc. We have spoken about the area of a sector, the perimeter of a sector. Okay, the length of a chord. We came to circle theorem properties that will help us. Why did I say circle theorem properties? Circle theorem, my bad. It's better I say circle theorem, okay? This is wrong math English. Let me clean this one quickly. Yeah. Then we came here to look at a very important theorem. This one, very common, where you've got the same shape. Okay, the triangles have the same shape. We spoke about the cosine rule and the sine rule. So now I think we are good to answer questions. Watch the next video for the questions. All right, have a lovely day. Don't forget to like and subscribe. Bye bye. See you in the next one.